In this example, we'll be going over creating an equation to represent information in a word problem. So take a moment to pause the video and read the problem. Okay, so what we'd like to do to start here is to create a table so we can organize Gerard and Hubert's information so we can create an equation based on it. So I'm just going to create a small table here where I have a row for Gerard and a row for Hubert, and then a row at the end for both of them. And what I want to do is compare the time it takes them each to assemble the playset, and then finally the rate at which they assemble the playset. So I'd have Gerard here, I'll have Hubert here, and both of them at the bottom. And here I'm going to have the time it takes them to assemble versus how much they can get done in an hour. So the time it takes Gerard to put this together is 5 hours longer than Hubert. So I'm going to call Hubert's time X, which means Gerard's going to take 5 hours longer than X, so his will be X plus 5. And it says together they can assemble the playset in 6 hours. So for both of them I'd have 6 here. So now the rate Gerard works at is 1 over X plus 5. The rate Hubert works at is 1 over X, and the rate they do it together is 1 over 6. In 1 hour they get a sixth done. So what we've created here is really an equation that relates the rate at which Gerard and Hubert do this to the rate they do it together. So writing that out in a linear form, or across the page, I'd have 1 over X plus 5 plus 1 over X is equal to 1 over 6. So now I'd like to multiply each of these by a common denominator, which in this case would be 6 times X plus 5. So writing that out over here just so we can see it, we'd have 6 times X and X plus 5. So I'm going to multiply each of these by that common denominator. So now we're going to look for stuff that's common in what we multiplied by and the original denominators we had set up here. So you can see X plus 5 is going to cancel here. X will cancel in this expression, and 6 will cancel right here. So that's going to leave me with 6 and X in the top of the first one. It's going to leave me with 6 outside of X plus 5 in the second one. And it's going to leave me with X outside of X plus 5 in the third one. So I need to distribute my 6 in the second bracket there, so that's 6x plus 30. I need to distribute my x on the other side there, so that's x squared plus 5x. So now I'd like to move everything to one side. So I'm going to have 12x and 30 on this side, but I'm going to be moving those. So this side is now going to be equal to 0. I'm going to have 0 equals x squared plus 5x. If I subtract 6x twice, that's going to be minus 12x. Subtract 30. So I'm going to simplify this a bit farther. I'm going to have x squared minus 7x minus 30. So now I'd like to factor that. So two numbers that multiply to give me negative 30 but add to give me negative 7 would be a negative 10 and a positive 3. So using the zero product property, what I get next is that x equals a positive 10 or x equals a negative 3. Now, looking at both of these solutions, one is 10 hours and one is minus 3 hours. Since we're talking about a real-life situation here where we have someone building a playset, they would not be able to do it in negative time. So we'd have to reject that answer first off. And then we just want to look at the 10 to see if it makes sense. So if it takes both of them 6 hours to complete the job, individually it should take them longer. And if we look at this, we can see that X is 10. So that means that Hubert takes 10 hours, which is longer than 6, which is what we're looking for. Also, for Gerard, his is X plus 5, so it would take him 15 hours to assemble the same playset. So since both of these times are longer than it would take them to do it together, this makes sense, and we can be confident that our answer is correct.